In this video, I'm going to describe the entire process for Team 2013 going from CAD to CAM. So in this case, we're going to be doing 4 gearbox plates. So first, you're going to want to go to the Part Studio, and then we want to cut out this plate here. So you're going to want to right-click that front face, export as .dxf or DWG, which is just a 2D file type. Download that one, and then that only does this face that's highlighted here, but we also want to cut out this face here, which is indented. So all you have to do is export that separately. Once you have them both downloaded, open up Cut2D Pro, or create new file. I'm just going to enter some values here. These don't have to be super accurate yet, except for this one. So it's just width of our material, height, thickness. We're cutting this out of 1/4 inch plate. Inches. We're always going to be zeroing on the material surface, not the machine bed. The day and position will always be in the top right with 0 offset. So you can select OK. Next, we're going to want to import vectors from Gearbox 1, our first file that we downloaded. Then that's OK. Import vectors again. And the second one, which it is exactly where it should be. Next, I'm going to select all these things and say join open vectors, which just closes all of them so that this is all one line. So if I undid that, each of these little segments are one little segment, which the CAM program does not deal with. So selecting everything, join vectors, and then so right now it's like that. It's all different. Also, I'm going to group everything, which will be more apparent a little bit later. So next up, we want 4 of these. Control-C, Control-V, Control-V again, and one more time, because we're making an entire drivetrain. And I'm just going to increase this a little bit. Okay, next, if you select everything, and then you go to Nest, we have some values there. Our tool diameter is 6 millimeters, which that might accept, but it's only getting inches. So then 6 millimeters to inches, which is like, we'll just say 0.23. Clearance, we don't need that much clearance. Border gap, 0.1's fine. Next up, how many degrees it can go, doesn't really matter. This just allows it to turn more efficiently. And it can mirror, since these parts are identical, they cannot go inside of the other parts. That would defeat the purpose. And that's from the top right. And that looks good. Preview it. And right now they're all going that way, which is okay. We can probably, that looks almost good enough. Okay, next, we'll say okay. It'll accept that. So now each part's like that. Next, we want to ungroup everything. So just ungroup it all. So they're all one piece. And then we can move on to the next step. So this is all the sketching portion of it. Next up, if you switch to toolpath commands, we get to the actual toolpaths. So our first toolpath is going to be our drilling toolpath. So for this one, we're cutting out these holes, and the bit we always use for that one is going to be the 0.191, which is the number 11 tool bit, which is used for 1032 clearance or 1/4 20 tapped. So I already have all the information here. All of our tool base can be found in here. Oh, it's in the drive if you look for it. Select that. Then we can just select all the points. There's not that many, so it's not that big of a deal. But you can also select everything at once and just deselect some points. But only these outer ones we want done with that bit. So once we're all selected, our cut depth is going to be 0.25, which is our material thickness, plus 0.06, so it's like a 16th over. Just because when the drills, it needs to go a little bit deeper. We just use spec drilling, and I'm gonna name this number 11 because that's the tool bit. Calculate, it's going to go through it, but we have a spoil board underneath, so we're fine. Okay, then if you want to preview it, that's the first cut. Go back to 2D view. Our next one that we're going to do in the drilling toolpath is we're going to be tapped 1032. So then that bit's the 0.1695. So that's the tapping for 1032. We can select that one. The only ones that we want tapped for these, it's not that many. That's it. And then I'm just naming the one. That same information looks okay. You can also do just the 0.25 plus 0.06. Calculate. It's gonna give all it through. Preview it. Looks good. And then, so there's, next up, what we're going to do is we're going to pocket everything in here. So there's two different types of material removal paths. There's the profile toolpath and the pocket toolpath. Profile, actually I'll just demo both of them. So if I just choose this one, with the 6mm bits, and I'll do that one. Okay, and then I'll also show a pocket alongside of it. So that when we preview that one. Okay, so the differences are that a profile will just go around the outside once, while a pocket will get rid of all the material. In this case, we're going to want to use a pocket, because if there's a little bit of material left in there, with our current setup, it can jam the bit, and we can start welding chips, which is not good. So pocket, for this one, it's 0.25 plus 0.01 seems to work. 6mm bit. It is a aluminum. We're not using large area. No offset. We're going to ramp the material thickness. So if there's 1/8 inch, you do 1/8 inch ramp. This is 1/4 inch, we're doing 1/4 inch ramp. And then I'm just going to select everything and then deselect what I don't exactly want pocketed. But most of everything I do want pocketed, except for some of these drill bit holes, and also the outside one we don't want pocketed because that one's different. That one will be a profile, since we just want to cut the outer part of it. Okay, and then that'll pocket it all, and then I'm just gonna name it like number 6 pocket. Okay. Oh wait, I forgot to deselect one of them. we do not want this one, that one, or that one, because we'll do that one later. Okay, now if we preview that, wait, it should just fly through it, cut it all out. This one, I didn't reset the preview, so it still looks like that. But if I redo it, those are looking pretty good. Next up is the profile. We're gonna do the outer profile. Just like those outer profiles. And then, okay, actually before we do that, I want to do the counter bore. So if we go to the CAD, we can see that it is a 16th counter bore. So then if we go over here, we still want the 600 bits. This time we want a 16th counter bore, and then I'm just going to select that, and that one, 16th. We want the inside of it. Looks good. Add ramp. We'll do a 16th ramp. Okay, also in this one, I selected the correct tools. Okay, wait. So now, okay, I did. So I selected the round holes in this one. So if we go here, I don't want that outer hole, I want the inner hole. So I'm going to deselect that one, select that one, call it through, reset preview, cut that, and then this profile, that one. This one didn't load. Okay, wait, now to go back into here. Oh, wait. There were two of them. Okay. Now it should work. Okay, so now you can see that there is a 16 counter bore right there, which looks pretty good. Then our profile, that one works pretty well. I don't know if I selected the correct bit for this one. I did, okay. Then we're doing one more profile, which is the outer profile. There. Add ramp. This one's quarter inch out with the outside. No separate last pass. Actually do a 10th. We don't need any tabs because we're gonna use screws to hold it down. And then bit, and then outer profile. Okay, wait, whoops, I've had the wrong thing here. 0.25 plus 0.01. Okay, now if all of them are loaded, now we have 4 gearboxes. The feeds and speeds in this one, I didn't really take time to get right, but we are fine-tuning these as we learn the machine. So these values will update as we learn it better. And then naming them with the proper names is always good. Once you're done with everything, you can save these toolpaths. You want to save them as a G-code inch, which is how our machine takes it. And then once you choose the right toolpath, you just save it. And then you export to the SD card. For the ones that have the same bit, such as these last 3, you upload all as 1 so that it finds the most efficient path for it all, instead of redoing all of them. And that is enough to get started camming stuff for our CNC.